Let's talk about this week's trending AI research. For this week, I want to focus on two world models, Google's DeepMind's Genie3 and Alibaba's LingBot-World. But first, what exactly is a world model like Genie3? A world model like Genie3 finds an environment and a character. It produces a world simulation that you can navigate in real time. You can control the character to move forward, turn, or change camera direction, and the model generates the next frame immediately all on the fly. Quite amazing, right? Nonetheless, Genie3 is a closed source project, so although we can appreciate its marvels, we don't have visibility into how it works. This leads me to introduce Alibaba's LingBot-World model, which was also recently released this week. But as an open source project, it has also been the recent trending research paper of the week. So I'll explain below in simple terms how this research model works. So first, LingBot-World is trained starting from an already strong video generation model, WEN 2.2, a 14 billion diffusion transformer model developed also by Alibaba. Then the team goes through three training stages, pre-training, middle training, and post-training, to arrive at the LingBot-World model. For the first stage, pre-training, the goal is to continuously pre-train the base model to learn essentially how the world looks like. It aims to improve the model's understanding in world's textures, lighting, object shapes, and natural motion from training large-scale video dataset. However, this training stage introduces no architectural changes, and the model is essentially still a video generation model. Starting in stage 2, middle training, this is where the model training focus shifts from enhancing visual quality to learning about how scenes evolve over time under actions. This stage is also where the researchers introduces a mixture of experts design, creating two diffusion transformers experts in the denoising process. One expert handles global layout early in generation, while the other expert defines visual details later on. This causes the model size to double from 14 billion to 28 billion. Moreover, the researchers also injects user actions and camera motion as training inputs in this training stage, so generation is controlled by movements also. Finally, for the last stage, post-training, the goal is to make the model go much faster and converts generation format from full-length video output into one that streams out several frames at a time based on user actions and camera movement. This training stage enables the model to be real-time controllable as shown in Genie3's demo. To support the three training stages, the team used data sourced from open domain videos for realism and diversity, game data where frames are paired with user controls and camera parameters, and also synthetic data created from Unreal Engine. The team also created a specific data engine for profiling and labeling these resources, created not only camera actions as well as rich captions for each training sample. As for results, the LingBot-World is evaluated against other recent world models like Yumi 1.5 and HY-World 1.5 based on the video benchmark VBench. LingBot-World outperforms other models in terms of how responsive and realistic the environment feels under user control. And it also stood out in its strong visual quality and temporal stability during long interactions. The paper showed numerous qualitative evidence also. With Genie3